Okay, today is the last day in problem solving and data analysis, and some of this stuff like you know how to find the average, you know how to find the median, but there are some other things that we're going to add to it today. So like I said, measures of center. So if you're asked about the center of a distribution, those measures of center are either the mean, which is the average, or the median, which is the middle number. Sometimes when you're calculating the median, if you have an even number of numbers, then the median is going to be the average of the middle two. So it is possible that the median is not an actual number in the data set. And if you're uncertain about the mean and what I mean by average, you just add up all the numbers. And divide by how many you have. When we describe the range or the variability of a data set, it's the maximum minus the minimum value. You do report this as a singular value. So you actually subtract the max minus the min. You wouldn't just say 100 minus 5 or 5 to 100. You would say that the range is 95. Okay, so box plots are things that you've seen before, but just to make sure that you know what's going on in a box plot, each section of the box plot kind of represents a specific thing in the data set. So the far extreme here is the minimum value. Far extreme over here is the maximum value. And then you have this box, and this vertical line through the box is the median. And then here, this is your lower quartile, or Q1, on the left-hand side of the box. And then this is Q3, or what's sometimes called your upper quartile. So a few things about this. We said the median is the middle number. Essentially, your lower quartile is the median of the first half of the data. Your upper quartile is the median of the second half of the data set. And they're called lower and upper quartiles, or Q1 and Q3, because they mark the quarters of the data set. So this span here from the minimum value to Q1 represents 25% of the observations in the data set. The span from Q1 to the median represents another 25% of the data set. And then from the median to Q3, or that upper quartile, is another 25%. And then here is your final 25%. So even though visually it might not look like a quarter, a quarter, a quarter, and a quarter, each of those chunks is representing 25%. You can just see here that the bottom 50% of this data set is more compact or condensed than the top 50% of this data set, for example. So then when we talk about data collection, this really tells us what kind of conclusions we can make. So I have some information here about different types of data collection, and then how we can make sure we have a well-designed study, and how we can make conclusions about a population from a sample. So one type of data collection method we have is an observational study, and that's when you just observe characteristics of the population, so you don't attempt to influence their responses in any way. So there's an example, just watching jaywalkers at an urban intersection. You're not going to mess with the lights or the walk signals. You're just going to watch what they currently do in their natural environment. Then we have an experiment, and an experiment is almost a must if you want to try and draw conclusions. So we'll say we need an experiment that's well designed draw conclusions. So if we want to say that something actually causes another thing to happen, or if we want to say that some medication does in fact work, we need to perform a well-designed experiment. And so something is considered an experiment if you apply a treatment to part of the population and then observe their responses. And so if something is a well-designed experiment, you have usually a control group. So this is a group that either gets a baseline treatment, or maybe they get no treatment. But maybe that no treatment is actually a placebo. So maybe you have them take a sugar pill. So they think they're taking a medication that maybe would lower their blood pressure, when in reality, they're just taking a sugar pill. So that way, maybe if there's some kind of mental effect of just taking this pill, you're going to see that in the results. So here I kind of wrote on top of it, but an example would be testing if a new medication reduces the risk of heart disease. So you would give some of the population this new medication and then test to see what the outcome was. Another type of data collection that you have is considered a simulation. And so that would be either using a mathematical model, like maybe random digits, or a computer model, or a physical model, which could be something like rolling dice and looking at those outcomes that would reproduce the conditions of some scenario. Like I said, a lot of times it's going to use computers with some sort of mathematical model, and you use a simulation when something's not ethical to conduct an experiment. So here, like impractical or dangerous study situations would be an example. So here, studying the effects of a car crash using test dummies. So you wouldn't just put people into a car and crash them into a wall to see what would happen. That would be unethical and unsafe. So instead, they put these computerized test dummies in the car and they record all of the information about the impact of the crash. So we have surveys as one way to collect data. So that's just going to be looking at measuring different characteristics of the population. One example is a census, where they're attempting to contact everybody in the population. And the census is currently going on, so you may have had family members fill out a census form or had somebody call or come to your door asking you to complete the 2020 census. So your assignment is that center, spread, and shape of distributions. We didn't really talk about shape, so just a couple of things that may show up here. If you have some kind of a graph and you can draw a smooth curve over it, that would be considered symmetric if the left and right hand sides are about the same. If you see multiple peaks in the data set, so if we have two peaks, that would be called bimodal. And then we also have skewed distribution. So we call something skewed to the left if it's kind of stretched to the left-hand side. And then skewed to the right would be the opposite. So it's kind of stretched on the right-hand side. And then that's where you're going to see things also like the mean, the median, and range. As far as the data collection and conclusions go, so we talked about the data collection methods. You want to say, can I make a conclusion based on my data collection method? So does it seem reasonable based on the way my experiment was designed to draw conclusions about the population?